conservation of energy, also called the law of conservation of energy. Well, whenever an object moves in a system, we say that the total energy prior to the motion is going to be equal to all of the energy after the motion. Energy is conserved. Energy in a system remains constant. Energy is not gained and it's not lost. Energy can only be converted from one form to another. So the total mechanical energy initial is equal to the total mechanical energy final. So here's an example, a bowling ball which is dropped. So a bowling ball which has a mass of 7 kilograms is dropped from a height of 5 meters. And the question is, calculate the final velocity of the ball, which means the final velocity when it reaches the ground. Now, what I've done is I've rewritten the statement that I had earlier, total mechanical energy initial is equal to the total mechanical energy final, in a little shorter form, a more common way of writing it, which says sigma, Greek letter sigma. Sigma means total or sum of. Sigma EI, so the total energy initial, is equal to the total energy final. Most common way of writing it. And since we know that at the top, at 5 meters, our bowling ball is just kind of resting there, so it has no kinetic energy. And since the bowling ball is held at the highest height in this problem, we would consider that the maximum gravitational potential energy. So this is the total energy here. And that energy can be converted into another form of energy. So if we take the ball and we release it, what will happen is the ball will fall towards the ground. And when it reaches the ground, the height is 0. And for that reason, the gravitational potential energy on the ground is equal to 0, which means that all the energy now has converted into kinetic energy. And that's why I say that that's the maximum kinetic energy. So the forms of energy we're talking about now are gravitational potential energy and kinetic. There is one more, spring potential energy or elastic potential energy, but we'll save that for another time. So the two forms of mechanical energy, GPE and KE, the initial, we add all that up, and that's going to be equal to the final GPE plus KE. Again, all added up. In this case, we only have the gravitational potential energy, and that is going to end up being converted into kinetic energy. Now there's a neat thing that shows up here. You notice that the mass cancels, so that equation gets reduced down to this. Now that confirms that the motion of the ball does not depend on the ball's mass. All objects fall at the same rate. So we know that from our previous studies. So we can take that equation, rearrange it, and we'll get the final velocity is equal to the square root of 2ghi. And plug in the numbers, and then what happens is we get an answer which is negative 9.9. Now your calculator won't say that. Remember that the square root of 98 is equal to plus or minus negative 9.9. Now the fact that the bowling ball is traveling downward, we can then conclude that it's the negative answer that actually applies in this case. And that's because the ball is moving downward. So let's look at example 2. In this case, same bowling ball. What's the velocity of the bowling ball when it is at 2 meters above the ground? So it didn't make it all the way to the ground yet. So we know that the bowling ball is speeding up as it's moving downward. So it's getting faster and faster. And we figured out what the speed on the ground is, negative 9.9. So above the ground, it should be less than that. So what we do is we notice that when we're at the height of 2 meters, we have both gravitational potential energy and kinetic energy. The ball is still moving at 2 meters, and since it's at 2 meters, it still has gravitational potential energy. So the total energy is equal to the final. In this case, when we're in the initial position, we only have gravitational potential energy. And when we are in the final position, we have both energies, gravitational and kinetic. And then we expand the formula, and you notice that mass appears in all three, so we would cancel that. And we're reduced down to, well, we keep reducing and simplifying the formula. So going through these steps until we get a formula for this case, final velocity is equal to the square root of 2g hi minus hf. And notice that this formula is different from the previous one. So you can't just go memorizing the formula. It's not going to work that way. You have to start off with the sum of the energy initial is equal to the sum of energy final and expand it according to the particular problem. And in this case, since the object didn't make it all the way to the ground, we still have some leftover gravitational potential energy, which has to get accounted for. And we see that in that final formula. Now you can check the answer yourself, but I just noticed I made an error here. This should be negative 7.67 meters per second, as I explained earlier.